So I want you to think about the last time you were in a car.
Right.
Maybe you were just driving to work, sipping your coffee, and you hit one of those really jarring potholes.
Oh, yeah, the absolute suspension-destroying ones.
Exactly. You know the kind. You brace for the impact, completely expecting the dashboard to crack or your coffee to end up all over your shirt.
But usually it doesn't.
Right. Somehow, the cup stays somewhat steady, and the car doesn't rattle apart into a million pieces.
Which is actually incredible when you think about the physics of it.
It really is.
Yeah.
Or, let's switch gears entirely for a second. Think about a news clip you might have seen recently showing a defense system intercepting a target midair.
Okay. Quite the pivot, but I'm with you.
Well, we tend to obsess over the shiny badge on the hood of the car, right? Or the prime contractor's logo painted on the side of that missile launcher.
We definitely do. We love the brand names and the prime assemblers.
We do, but the true heroes in those scenarios are, well, they're entirely invisible to the naked eye.
Yeah, they're buried deep inside the machinery.
Exactly. They are these hyper-precise, completely unglamorous metal components that actually make the whole thing work.
It is a fascinating blind spot we all have as consumers, honestly. We buy the complex system, but we rely entirely on the subcomponents.
Right.
And the level of engineering required to ensure a shock absorber rod doesn't just snap in half after, 50,000 kilometers of daily abuse is staggering.
Let alone an artillery fuse, right?
Exactly. An artillery fuse operates with literal zero tolerance for error, even after sitting in a warehouse for a decade. The kinetic energy these parts have to absorb without warping is just intense.
And that invisible, highly stressed world is exactly where we are going today.
I'm really looking forward to this one.
Me too. Today's deep dive is into a company called OBSC Perfection Limited. They are a genuinely fascinating Indian precision engineering company.
They really are.
We're looking at a very comprehensive stack of data today. It details their product lines, their market strategy, their financial trajectory, and their quite literal physical footprint across India.
And the mission for this deep dive is to unpack a real-time case study in corporate evolution.
Yes, exactly.
We are looking at how a niche manufacturer of fairly unglamorous automotive parts is currently attempting a high-speed, high-stakes pivot.
They are trying to achieve escape velocity, basically.
Right. They want to break out of the fiercely competitive automotive sector and get into aerospace, defense, and global exports.
It's a front row seat to how manufacturers actually try to capture higher margin markets, but, without losing the foundational business that keeps the lights on.
It's a tricky balancing act.
It really is. I'm so energized by this one because it's just incredibly cool to see how the gears of industry actually turn.
Absolutely.
I mean, we're talking about a company trying to bridge the gap between truck exhausts and next generation tech.
It's a big leap.
Huge leap. So we need to start with the invisible connective tissue. What does OBSC actually make?
Right, the products.
Because no consumer has ever walked into a hardware store and said, yes, I'd like to purchase one sensor boss, please.
No, they certainly haven't. This is a strictly B2B ecosystem. OBSC Perfection is a precision metal component manufacturer.
Okay.
And to understand their bread and butter, you have to look at their two core product lines in the automotive space. First, like you just mentioned, is the sensor boss.
The sensor boss.
Yeah.
I have to admit, it sounds like a video game villain from the 90s.
It really does sound like that. But in reality, a sensor boss is a highly precision-turned metal part used in exhaust systems.
Mostly for heavy trucks and passenger vehicles, right?
Exactly. So to visualize it, think of the exhaust pipe running under your car. Modern vehicles are incredibly heavily monitored for emissions.
Right, because of all the environmental regulation.
Yes. So you have oxygen sensors, temperature sensors, all needing to read the exhaust gases in real time. But you can't just tape a delicate electronic sensor to a scorching hot vibrating pipe.
Well, obviously, you just melt or snap off instantly.
Precisely. So you need a mounting point. That is the sensor boss. It's a metal housing welded into the exhaust system that the sensor screws into.
Okay. That makes sense.
But here's the catch. It has to be machined to exact microscopic tolerances.
What happens if it isn't?
Well, if the threads are even slightly off, or if the thermal expansion of the metal isn't perfectly calculated, exhaust gas leaks out.
Which is bad.
Very bad. Or worse, the sensor gets bad data, the emissions control fails, and the vehicle's engine management system is essentially flying blind.
So it starts dumping the wrong mixture of fuel and air into the engine.
Exactly. OBSC exports a significant volume of these highly specific parts to Europe and the US, as well as supplying domestic Indian manufacturers.
That paints a really clear picture. It's the critical bridge between the brute force of the exhaust and the delicate electronics of the car's computer.
That's a great way to put it.
And the second core product.
Shock absorber rods. OBSC is one of the top-tier manufacturers of these specific components in India.
Now, just to be clear, they don't make the entire shock absorber unit, do they?
No, they don't. They don't make the spring, the fluid housing, or the outer casing. They just make the central critical metal rod that plunges in and out of the hydraulic fluid.
Okay, so that rod is taking the absolute brunt of the kinetic energy when you hit that pothole we talked about.
Yes, it is. So every time the wheel jolts upward, that rod is what is actually driving into the dampening fluid to slow the impact.
Wow.
And because of that, it has to be perfectly smooth, perfectly straight, and hardened to an exact specification.
So it doesn't bend, I assume.
So it doesn't bend, and so it doesn't score the seals inside the shock absorber. If that rod has even a microscopic imperfection, it will tear the rubber seals.
And then the hydraulic fluid leaks out.
Exactly, and your suspension is ruined. They supply these rods to the large-scale shocker manufacturers who then assemble the final suspension unit for the automakers.
You know, going through the data on this, the analogy that kept coming to my mind was human anatomy.
Oh, how so?
Well, if the internal combustion engine is the heart and the electron control unit is the brain, these precision metal parts, the rods, the bosses, the shafts, they are the cartilage.
Ah, I like that.
Right, they are the connective tissue. It's not the flashy part you show off at the gym. Nobody brags about their cartilage.
True.
But if your cartilage degrades, the friction destroys the joint, and the entire system grinds to a painful, screeching halt.
That is a highly accurate way to look at it. Without that precision cartilage, the friction, the heat, and the vibration would literally destroy the machine from the inside out.
Exactly.
And because it is so critical, the customers buying these parts are highly discerning. OBSC operates in a world where they sell directly to original equipment manufacturers, or OEMs, and large Tier 1 component makers.
We're talking about heavyweights in the industry, like Tata AutoComp and ZF.
Right. These are the giants that build the major subassemblies for the final vehicle.
And to service those kinds of demanding, huge clients, you need serious manufacturing muscle. You can't just be a couple of guys in a garage with a lathe.
Absolutely not.
The operational footprint highlights that OBSC has a 24-product portfolio. But what really stood out to me is that they do almost everything in-house.
Yes. That integration is key for them.
They aren't just taking a preformed piece of metal and drilling a hole in it. They are doing machining, turning, investment casting, fabrication, and forging.
It's a very comprehensive setup.
Can we break down what those actually mean? Because investment casting sounds like a financial term, not a factory process.
Yeah, it really does. But it is a critical distinction. The breadth of their in-house capability is central to their value proposition. Let's walk through the factory floor, conceptually.
Lead the way.
Investment casting, for instance, is an ancient technique updated for modern precision. It's also known as lost wax casting.
Oh, I've heard of that for jewelry.
Exactly, same principle. You create an exact replica of the part you want out of wax. You coat that wax in a ceramic shell, bake it so the wax melts and runs out, hence lost wax, and then you pour molten metal into that perfectly formed ceramic cavity.
That sounds incredibly precise.
It is. It allows a manufacturer to create incredibly complex, intricate shapes with internal geometries that a standard drill or milling machine could never reach. And it does so with minimal wasted material.
Okay, so that gets you the complex shapes. What about turning and machining?
Turning and machining are where you get down to the micrometer level of precision. This relies on automated CNC machines, computer numerical control.
So computers are doing the cutting.
Right. You take a solid block or cylinder of metal, spin it at high speeds, and computer-guided cutting tools carve it down.
That must be how they get the exact threading on those sensor bosses.
You nailed it. It gives them that exact repeatable precision required for something like those threads. You can program the machine once, and it will produce 10,000 parts that are identical down to the fraction of a millimeter.
And then there's forging, which I always just picture as a blacksmith hitting a glowing red sword with a hammer.
Well, the modern version isn't too far off in principle, just much more controlled.
Right, less anvils, more hydraulics.
Exactly. Forging, whether it's hot or cold, involves using immense mechanical pressure to deform and shape the metal. But it's not just about shaping.
What else does it do?
Forging physically alters the internal grain structure of the metal, aligning the molecular structure to make the part significantly stronger.
Oh, wow. I didn't know that.
Yes. By having all these capabilities, casting for complex shapes, CNC machining for micrometer precision, and forging for brute strength under one roof, OBSC maintains absolute control over quality, metallurgical integrity, and delivery timelines.
So they aren't relying on 3 different subcontractors who might drop the ball or miss a deadline.
Precisely.
So bringing this back to you, the listener, the takeaway here is that the next time you drive over a badly paved road or navigate a construction zone and you don't end up wearing that coffee you were drinking.
Take a second to thank the hardened, perfectly machined precision metal rods taking the beating on your behalf.
Yes, they are absorbing the chaos of the road so the driver doesn't have to.
Exactly right.
Okay, so making metal rods and exhaust mounts sounds like a very specific, almost narrow niche. I want to pivot from the micro level of the parts themselves to the macro level of the market.
Let's do it.
Why is this specific automotive sandbox so incredibly lucrative?
To understand the value, we have to look at the total addressable market, or the TAM, and the figures in India alone are quite revealing.
Just India.
Just India. The annual market for these precision metal auto components, specifically focusing on the segment that includes things like shock absorber rods, shafts, and sensor bosses, is estimated to be between 18,000 to 22,000 crores.
I need to pause on that.
Yeah.
18,000 to 22,000 crores. That is a staggering amount of money for components most people don't even know exist.
It really is.
Where is all that demand actually coming from? Is India just building that many new cars every year?
Well, new vehicle production is a part of it. India's passenger and commercial vehicle production is growing at a healthy 6 to 8% annually. But that is only the tip of the iceberg. The real secret to the durability and the sheer size of this market is the replacement cycle.
Right. Because things break.
It comes down to basic vehicular math and the harsh realities of physics and friction, especially on Indian roads.
Yeah, those potholes don't mess around.
They don't. A shock absorber doesn't last forever. It is a wear and tear item. The industry standard lifespan for these components is roughly 50,000 to 80,000 kilometers.
So for the average driver, depending on their commute, that translates to replacing them every 5 to 7 years.
Exactly. So on top of the millions of new vehicles needing fresh parts on the assembly line, you have this relentless built-in replacement demand.
Right.
The data suggests this generates another 1.5 to 2 million replacement units every single year. It is a constantly churning engine of demand.
Here's where the economics of this get really interesting to me. The market dynamics show that this replacement demand is essentially countercyclical.
It is, and that is a crucial buffer for manufacturers in this space.
Because they aren't just relying on good times.
Right. Think about a broad economic downturn. When interest rates rise, money is tight, consumer confidence drops, and people delay buying a brand new car.
Sure. The OEMs see this and naturally slow down their production lines.
But the economy doesn't stop. Those same people still need to commute to work. The logistics companies still need to move freight across the country.
So instead of buying new, they repair the old.
Exactly. They keep their current vehicles running longer. And as those vehicles age past that 50,000 kilometer mark, the owners are forced to replace the shock absorbers, the exhaust sensors, the worn-out suspension parts.
Because even in a recession, if your truck's suspension collapses, you have to fix it.
You have absolutely no choice. This aftermarket replacement cycle provides a baseline of demand that shields manufacturers like OBSC from the absolute worst of the macroeconomic swings.
It's a remarkably resilient business model. You're manufacturing a product that literally destroys itself through normal intended use and absolutely must be replaced for the machine to function.
It guarantees a customer base.
But let's talk about who is actually doing the replacing, because the market isn't a monolith. There is a fascinating 60-40 split happening right now in terms of who is supplying these parts.
Yes, the market structure in India is currently in a profound state of transition. At present, about 60% of the total demand, which includes both the new OEM parts and the organized aftermarket, is served by the organized sector.
Okay, and the organized sector means what exactly?
These are registered, certified manufacturers with strict quality controls, standardized labor practices, and traceable supply chains.
Got it.
But that leaves a very significant 40% of the market demand still being met by the unorganized sector.
And when we say unorganized, we are talking about local, non-certified machinists.
Correct. Small-scale, often unregistered workshops churning out cheaper, lower-quality, reverse-engineered replacement parts. And alongside that unorganized domestic production, there's also the factor of imports. Currently, about 15% of these components are imported into India, primarily lower-cost variants flowing in from China to serve that highly price-sensitive segment of the aftermarket.
Okay, so you have the organized players, the unorganized local shops, and the cheap imports all fighting for a piece of this 22,000 crore pie.
That's the current landscape, yes.
That landscape is shifting, right? The government is stepping in.
Significantly. There are powerful structural forces shifting the balance of power toward the organized sector. The Indian government has introduced strict new quality regulations and standards.
Like what?
They're requiring certifications from bodies like BIS, which is the Bureau of Indian Standards, and ARAI, the Automotive Research Association of India.
And these aren't optional, I assume.
No, these mandates aren't just suggestions. They demand higher metallurgical quality, absolute traceability of parts in case of recalls, and stricter emissions compliance, aligning with things like the Euro 6 standards.
So you really can't just slap a piece of metal together and call it a shock absorber anymore.
Exactly. Furthermore, rising global logistics costs and geopolitical friction are making those cheap imports from China less reliable and less economically attractive.
Oh, that makes sense.
This combination of strict domestic regulation and global supply chain friction is driving a wave of import substitution.
So it's pushing people to buy local, but organized local.
Right. It is actively pushing the market away from the unorganized local shops and the importers and funneling that demand toward domestic precision manufacturing companies that can actually meet the new legal standards.
Okay, I have to push back on this a little bit because I think we need a reality check on how consumer behavior actually works.
Sure, go ahead.
I understand the government is pushing regulations, and I understand the theory of import substitution.
Right.
But let's say I take my 6-year-old hatchback to my local independent neighborhood mechanic because the suspension is completely shot. Is that mechanic really going to stop buying the cheaper, unorganized part from the supplier down the street just because of a new BIS regulation?
Probably not.
Right. I mean, human nature dictates we go for the cheaper option when the car is already out of warranty. The local guy wants to protect his margin, and I want a lower repair bill. Does regulation really beat price at the neighborhood garage level?
It is a very fair challenge, and your skepticism is warranted. In the deep, unorganized aftermarket, the neighborhood garages servicing older, out-of-warranty vehicles, price sensitivity remains incredibly high.
Yeah, they just want it fixed cheap.
A local mechanic will absolutely still try to source the cheapest viable part to keep the repair bill down. The formalization of that specific segment will take a very long time.
So how does OBSC win then?
Well, to understand OBSC's trajectory, we have to view this through the lens of their specific customer base. OBSC isn't deploying a sales team to sell one-off rods to your corner garage.
Oh, so they are just ignoring that entire segment.
Their strategy completely bypasses that bottom 40% of the market.
How so?
Yeah.
If they aren't selling to the local mechanics, who are they prioritizing?
They are prioritizing the locked gates of the industry. The most lucrative parts of the market, the direct supply to major OEMs for new vehicles, the authorized dealership networks, and the rapidly growing export market are firmly locked behind a wall of certifications.
Ah, okay.
For an OEM like Tata AutoComp or a procurement manager in Europe or the US, price is a factor, of course. But quality, reliability, and legal compliance are paramount.
So they wouldn't touch an unorganized supplier with a 10-foot pole?
They legally cannot and will not buy parts from an unorganized supplier. They require their suppliers to hold specific, rigorous global certifications like ISO 9001 for quality management and the crucial IATF 16949 standard.
IATF 16949, what does that actually entail? Why is it such a big deal?
IATF 16949 is the global quality management standard specifically for the automotive industry.
Okay.
It requires a manufacturer to prove they have processes in place for continuous improvement, defect prevention, and the reduction of variation and waste in the supply chain.
That sounds like a lot of paperwork.
It is. It means an auditor can walk into your factory, pick up a shock absorber rod, and you have to be able to show them exactly which batch of steel it came from, the temperature of the forge on the day it was made, and the calibration records of the CNC machine that cut it.
Ah, so it's not just about making a good part. It's about proving you can make 1,000,000 good parts exactly the same way, with a complete paper trail.
Exactly. It is a non-negotiable gatekeeper.
Wow.
An unorganized local machinist cannot walk into a Tier 1 auto supplier and win a contract, no matter how cheap their parts are, because they lack the paper trail, the automated CNC consistency, and the certified quality control systems.
So the formalization push isn't necessarily about changing the local mechanic's mind overnight.
Right.
It's about the entire top tier of the industry, the most profitable, 60% consolidating their enormous supply chains around a smaller pool of players who can guarantee precision at scale and pass an audit.
And that is exactly where OBSC is firmly positioned.
That clarifies it perfectly. You don't need to win the bottom 40% if you are consolidating your grip on the top 60%, especially when that top tier is growing through exports.
Exactly.
Which brings us to a really critical question about competition. If this market is a 22,000 crore sandbox and the organized sector is consolidating, why doesn't a giant conglomerate just crush a smaller player like OBSC?
It's a great question.
Right. We know there are huge multi-billion-dollar forging companies in India. How does a subscale company not just survive in the shadow of giants, but actually thrive with 19% operating margins?
That is the defining question for any mid-cap manufacturer in a heavy industry. How do you survive the giants when they have infinitely more capital?
So how do they?
For OBSC, the answer lies in what you could call a structural cheat code. It is entirely about how they have physically configured their supply chain.
Yes. When I was looking into their physical footprint, this felt like discovering a secret level in a video game.
It really does.
The cheat code is geographic co-location. OBSC operates 4 manufacturing plants. 3 of them are clustered in Pune in the state of Maharashtra, and 1 is in Chennai, down in Tamil Nadu.
Both major hubs.
Right. Both of those cities are well-known automotive hubs. But it's not just that they are in the right cities, it's where they are located within those industrial zones.
Exactly.
They're physically co-located right next door to their raw material steel suppliers.
It seems like a mundane logistical detail on paper, but the economic impact of that proximity is profound.
How much of an impact does it really make?
Huge. In metal manufacturing, your heaviest, most expensive, and most cumbersome input is raw steel. Moving tons of steel coils or billets across the country on diesel trucks eats into your margins at a terrifying rate.
Oh, because freight is so expensive.
Exactly. By being physically adjacent to the steel suppliers, OBSC virtually eliminates the middlemen and the transportation friction. They slash their inbound freight and logistics costs to almost zero.
And it completely changes how they handle their inventory, right?
Yeah.
If the steel is next door, you don't need to hoard it.
Completely. It allows them to run a true just-in-time inventory model on the raw material side.
Which saves a ton of money.
Right. They don't need to tie up millions of rupees or build giant warehouses holding stockpiles of raw steel hoping it doesn't rust. The source is essentially a forklift drive-away.
That is amazing.
This creates a powerful geographical moat. If a well-funded new competitor decides they want to challenge OBSC on cost, that competitor has to acquire expensive, scarce industrial real estate in those specific, already crowded zones.
And build a factory from scratch.
And establish those localized supply lines. It is incredibly capital-intensive and time-consuming to replicate that exact physical setup.
It's brilliant in its simplicity. You win the margin game by simply not paying for trucks to drive your heavy steel around.
It's highly effective.
But there is another layer to this ecosystem advantage that goes beyond just the map. OBSC isn't a standalone startup that appeared out of nowhere. They're part of the Anglian Omega Group, which has a 55-plus-year legacy in the Indian steel and manufacturing industry.
That group legacy provides a substantial, often hidden financial lever. Because OBSC is integrated into this decades-old steel procurement ecosystem, they have established deep, high-trust relationships with their suppliers.
They've been around a long time.
And the suppliers know the group is reliable. And in business, especially in heavy industry, trust and volume translate directly into favorable payment terms.
Let's unpack the working capital magic happening here, because this is where the business really hums. The financial data indicates that OBSC enjoys unusually short payable days for their raw materials.
Yes. In the auto component industry, managing your cash cycle, the time between when you pay for your materials and when your customer pays you for the finished product, is a matter of life and death.
Okay, so what do their metrics look like?
The metrics show OBSC has payable days hovering around 30 to 35 days. This means they take delivery of the raw steel today, they can immediately start machining it, but they have roughly a month before they actually have to wire the cash to the steel supplier.
Wow, 30 days is a huge cushion.
It is. Because of the Anglian Omega Group's bulk procurement power across its various entities, OBSC gets preferable, lenient treatment that a standalone, mid-sized competitor simply wouldn't be granted.
So they have significantly lower logistics costs because of the physical geography, and they get to hold on to their cash longer because of the familial group legacy.
Precisely. It is a dual advantage. And when you combine the elimination of freight costs, the efficiency of just-in-time inventory, and the favorable payables giving them a cash float, you get a highly optimized cost structure.
Which leads to those margins.
This is the exact mechanism that allows them to maintain EBITDA margins around 19%.
And in the highly competitive, notoriously margin-thin world of Indian auto ancillaries, where OEMs constantly squeeze suppliers for price cuts, maintaining a 19% operating margin is robust.
Very robust. It significantly outpaces many of their direct peers. It's how the smaller, smarter player defends its castle against the sheer scale of the giants.
Okay, so we've established they have fantastic, well-defended fortress in the automotive sector. Great margins, deep geographical moats, certified quality. But there's a structural problem.
There is indeed.
The broader industry data indicates that even with all these advantages, the automotive sector has a hard ceiling. The margins, while good for OBSC currently, are ultimately capped by the fierce competition and the extreme bargaining power of those massive automakers.
That's the reality of the auto sector.
Right. If Tata or Mahindra demands a 2% price cut next year, you usually have to find a way to give it to them. We are looking at auto sector margins generally capped at 10% to 15% across the board.
Which is tough.
So if OBSC wants to truly scale and increase its profitability, they can't just keep making more shock absorber rods. They need an escape velocity strategy. They need a pivot.
And that pivot is exactly what is playing out right now, and it is the most compelling part of their corporate narrative.
It really is the most exciting part of this data.
They are taking their core competency, the highly certified precision machining of metal, and aiming it at entirely new, significantly higher value industries.
Specifically, they have engineered a breakthrough into the aerospace and defense sectors.
Exactly.
The numbers on this pivot are honestly wild to read. Let's look at the trajectory. In the fiscal year 2024, their revenue from the defense sector was essentially a rounding error. It was a mere 28 lakhs. It was practically nothing.
Barely on the radar.
But by FY25, just 1 year later, that defense revenue skyrocketed to 5.55 crores. And it's not just a one-off spike from a pilot program. They have secured a foundational anchor order.
Yes, the anchor order changes the entire trajectory of the company. They secured a 130 crore order spread over a 10-year horizon.
130 crores, that is huge.
And we need to be clear about what they're making. This isn't for truck exhaust mounts or brackets for military jeeps. This order is for precision components used in ammunition and artillery fuses.
Wait, really?
Furthermore, they are developing critical mating parts for missile systems.
Okay, wait, hold on. I have to push back here because this sounds like a giant leap of faith. You are telling me that the defense establishment is trusting a company that makes mounts for truck mufflers to build the fuses for high-explosive artillery shells.
That is exactly what is happening.
How is that not a catastrophic risk? The engineering requirements between a truck hitting a pothole and a missile intercepting a target have to be worlds apart.
It sounds like a jarring leap, I agree. But you have to look at it through the lens of the manufacturing process, not the final product.
Okay, explain that to me.
A CNC machine doesn't know if it is cutting a sensor boss for a diesel truck or a titanium housing for a missile fin. It only knows the G code it is programmed with and the tolerances it must hold.
But the tolerances for an artillery shell must be insane.
They are absolute zero tolerance. Consider the physics of an artillery fuse.
Oh.
It has to sit in a humid storage bunker for maybe 10 years without corroding. Then it is loaded into a cannon. When fired, it is subjected to thousands of G-forces of acceleration instantly,
Which would crush a normal part.
followed by massive centrifugal forces as the shell spins through the air. And after all that violent kinetic trauma, the mechanical timers and the arming rotors inside that fuse have to align perfectly so it detonates at exactly the right millisecond over the target.
Wow. If it's a millisecond off, what happens?
If it detonates a second early, it explodes in the barrel. If it detonates late, it's a dud.
Right, so the stakes are literally life and death.
Exactly. The fact that the defense industry audited OBSC and trusted their in-house capabilities to machine those specific life-critical parts speaks volumes.
It really does.
It proves that their investment in high-end CNC turning, their metallurgical control, and their quality assurance systems are truly world-class. They aren't just an auto parts maker, they are a precision engineering firm that happens to have started in auto.
Okay, I see the through line now. The core skill is cutting metal perfectly, regardless of where the metal goes.
Exactly.
But beyond the undeniable cool factor of moving from cars to missiles, why does this matter so much financially?
It matters entirely because of the margin uplift. We talked about the auto sector gross margins being structurally capped around 10% to 15%.
Right, the ceiling.
When you move into defense, aerospace, and marine components, the barrier to entry is exponentially higher. You need specialized certifications.
Like what?
Like the AS9100D, which is the aerospace equivalent of the automotive quality standard, and which OBSC is actively pursuing. Because the required precision is so extreme and so few companies can actually pass the audits to make these parts, the pricing power shifts dramatically back to the manufacturer.
So you aren't fighting 50 other suppliers for a contract. You might only be competing against 2 or 3.
Exactly. And because of that scarcity of qualified suppliers, components in these aerospace and defense sectors routinely command margins in the 20% to 25% range.
Oh, wow. That's a huge jump.
Sometimes significantly higher, depending on the complexity.
So every rupee earned in defense is fundamentally more profitable than a rupee earned in automotive.
Precisely. And the company's management is executing a very deliberate mathematical strategy to shift their overall revenue mix. Historically, they were about 90% reliant on the automotive sector.
Right.
They are actively trying to pull that automotive reliance down to about 65%.
And the rest.
The goal is to allow the remaining 35%, that high-margin non-automotive slice containing the defense, marine, and aerospace contracts, to act as a powerful engine, pulling up the company's overall blended profitability.
Okay, I have to bring up a detail from the product pipeline that genuinely made me do a double take. We are talking about defense and artillery,
Yeah.
which is serious, heavy industry business. But the documentation also lists that they're developing parts for the renewable sector, specifically solar fasteners and humanoid parts.
Yes, humanoid parts.
Humanoid parts. Are we talking about robotics here? I was trying to wrap my head around how a company making shock absorbers for a Mahindra truck is suddenly preparing for next generation humanoid robotics.
It sounds entirely like science fiction, but it is actually a highly logical, forward-looking extension of their core capabilities.
Okay, I'm listening.
Think about what a humanoid robot actually is from a mechanical standpoint. At its core, it requires dozens of highly complex miniature actuators, precision joints, and durable connective frameworks to mimic human movement.
Sure.
It requires exact tolerances to move smoothly without shuddering or snapping.
So it's basically a highly complex miniature suspension system.
In many ways, yes. The exact same CNC machining, the investment casting, and the precision turning expertise that creates a flawless sensor boss or a perfectly balanced artillery arming rotor is exactly the skill set needed to machine the structural titanium or aluminum components of a robotic arm or a knee joint.
That's wild to think about.
By taking on the R&D and getting their foot in the door with humanoid parts right now, they are positioning themselves at the ground floor of a robotics industry that could absolutely explode in scale over the next decade.
That is just incredible foresight. It's taking a legacy skill and pointing it squarely at the future. But it's not just new futuristic industries they're pivoting to, it's entirely new geographies. The data highlights an export strategy that is really taking off.
The export narrative is a critical, perhaps the most immediate pillar of their growth strategy.
How big of a pillar are we talking?
Well, currently, exports make up about 20% of their total sales. They are actively shipping precision components to 17 different countries.
Okay, that's solid.
But management isn't stopping there. They are targeting a very aggressive expansion, stating an aim for exports to constitute a full 40% of their total revenue by FY29.
Why the sudden aggressive rush to export? Is it just to diversify away from the Indian market?
Diversification is certainly part of it, but they are primarily trying to capture a global macro trend known in the industry as the China Plus One strategy.
Oh, right, I've heard of this.
Following the severe supply chain shocks of the past few years, the pandemic disruptions, the geopolitical tensions, the shipping lane crises, major European and U.S. buyers had a harsh awakening.
They realized they put all their eggs in one basket.
Yes, they realized they were dangerously, almost existentially over-reliant on Chinese manufacturing for their critical components.
If the factory in Shenzhen shuts down, the assembly line in Detroit grinds to a halt.
Exactly. So these large Western corporations are now actively seeking secondary sourcing hubs to mitigate that geographical risk. They aren't leaving China entirely, but they want a plus one alternative.
And India is raising its hand to be that plus one.
India, with its rapidly improving logistics infrastructure, favorable government policy environment pushing manufacturing, and established, deeply skilled automotive clusters in places like Pune and Chennai, is a prime beneficiary of this shift.
So OBSC is just riding that wave.
OBSC, armed with its global certifications like IATF 16949 and its push for the AS 9100D aerospace standard, is perfectly positioned. When a European buyer comes looking for a non-Chinese supplier who can guarantee aerospace-level precision, OBSC is raising its hand with the paperwork to prove it.
Okay, let's step back and look at the big picture we've painted so far. We have a company with a brilliant geographic cheat code on their raw materials, pulling off a highly ambitious, highly profitable pivot into defense, robotics, and global exports.
It's a very compelling story.
It is a fantastic story.
Right.
But as anyone who has ever tried to scale a business knows, you have to spend serious money to make money. This kind of aggressive pivot, hunting aerospace contracts and doubling exports, isn't free. You need machines, you need space.
You absolutely do.
How is OBSC funding this growth? And what are the actual economics of scaling this operation up?
This is where we transition from the strategic vision to the hard, cold mechanics of the balance sheet and factory operations.
Let's get into the numbers.
To capture these new markets, OBSC is currently in a phase of heavy capital expenditure, widely known as CapEx. The financial filings detail significant investments aimed at substantially increasing their physical output capacity.
The filings mention a specific funding event, right? A 43.3 crore preferential issue.
Yes.
They raised this capital, and the stated purpose for that money was to fund the expansion of what they explicitly call mega factories. That is a bold Elon Musk-style term to use.
It signals their sheer ambition and the scale they are targeting. A key piece of this physical expansion is a sprawling new plant located in Supa.
Supa, okay. What are the projections for that?
Management's projections for this specific facility are highly optimistic. They anticipate that once the Supa plant is fully online, reaches peak operational efficiencies, and hits full capacity utilization, it alone could generate between 700 to 800 crores in annual revenue.
I need to contextualize that. 700, 800 crores from one new plant, when their trailing 12-month revenue for the entire company prior to this was around 223 crores.
A massive jump.
They are talking about tripling the size of the company's output with one facility. That is a huge scale-up.
Yeah.
But help me understand the factory math here.
Sure.
How does building these huge, expensive factories actually improve their profit margins? Don't bigger factories just mean bigger electricity bills, more staff, and heavier debt?
They do mean bigger doles initially. To understand how this translates to higher profitability, we need to look deeply at the core manufacturing concept of operating leverage.
Okay, operating leverage.
In any factory setting, your costs are broadly divided into two distinct buckets: variable costs and fixed costs.
Okay, let's break that down for the listener in the specific context of OBSC making metal parts.
Certainly. Variable costs are exactly what they sound like. They vary directly with the number of items you produce. For OBSC, the primary variable cost is the raw material itself, the steel and the aluminum. If they receive an order to make one shock absorber rod, they buy a small amount of steel. If they receive an order to make 1 million rods, they buy a large amount of steel. The material cost per individual rod remains relatively flat. You only pay it when you make the product.
Got it. That makes sense. And the fixed costs?
Fixed costs are the bills you have to pay regardless of whether the factory is running at 10% capacity, churning out a few parts, or 100% capacity, running 3 shifts a day.
So the rent doesn't care if you're busy or not.
Exactly. It includes the land lease, the administrative salaries, and crucially, the biggest fixed cost associated with building these mega factories, depreciation.
Right, depreciation. The accounting cost of the wear and tear on the buildings,
Yeah.
those incredibly expensive CNC machines over their useful life.
Exactly. When OBSC spends tens of crores of rupees buying new state-of-the-art German or Japanese CNC machines for the Supa plant, that creates a large fixed depreciation expense that sits on their income statement every single year. Right now, in this early building and testing phase, those heavy fixed costs are actually compressing their profit margins slightly. They are paying the mortgage on a giant factory that they aren't fully utilizing yet.
Here's an analogy that always helps me visualize operating leverage.
Oh, I'd love to hear it.
Imagine you decide to start a commercial baking business. Instead of baking in your small apartment, you go out and rent a giant professional commercial kitchen. Your rent for that kitchen is 1,000 rupees a day. That is your fixed cost.
Well, simple enough.
The flour, the sugar, the eggs, those are your variable costs. Now, the first few weeks, you were just starting out and you only get orders for 10 cakes a day. So you take your 1,000 rupees rent, divide up by 10 cakes,
Wow.
your rent cost per cake is 100 rupees.
Which eats all your margin.
It's agonizing. It eats almost all your profit. But a year later, your marketing kicks in, your business takes off. You are now baking 1,000 cakes a day in that exact same kitchen.
The rent is still 1,000 rupees.
Your rent hasn't changed. It is still 1,000 rupees a day.
Yeah.
But now, your rent cost per cake is only 1 rupee. The fixed cost becomes a tiny, insignificant afterthought, and your profits soar because every additional cake sold drops almost pure profit to the bottom line.
That is a flawless explanation of the mechanics of operating leverage. It is the holy grail of manufacturing.
So that's what OBSC is trying to do with SUPA.
Exactly. As OBSC ramps up production in these new mega factories as they start machining 1,000 parts instead of 10, bringing in those large defense and export orders, the heavy fixed depreciation cost of the factories spread out over a vastly larger number of units. The fixed cost per unit drops rapidly.
And what are they targeting with that?
Management is targeting a 4% to 5% expansion in their EBITDA margins over the next 3 to 4 years. They expect to achieve this purely based on this operating leverage taking hold as volumes rise, combined, of course, with the product mix shifting toward those higher margin defense and aerospace parts.
It is an incredibly powerful financial engine once it gets up to speed. But operating leverage is also a notorious double-edged sword, isn't it?
It absolutely is.
Which brings us to the cracks in the armor. We have this aggressive, highly optimistic growth narrative. Management is targeting 40% to 45% revenue growth in FY27. But what happens if the music stops? What are the actual tangible risks and vulnerabilities lurking in this business model?
The primary vulnerability is tied directly to that very same operating leverage we just discussed. Let's call it the cyclical auto threat.
Right.
Despite the impressive, flashy pivot toward defense and aerospace, the sober reality today is that OBSC is still heavily reliant on the Indian commercial and passenger vehicle markets for the vast majority of its cash flow.
And the auto industry is famously cyclical.
Notoriously brutally cyclical. It booms, and then it busts based on macroeconomic factors completely outside OBSC's control: interest rate hikes, inflation, consumer confidence drops.
So going back to our commercial kitchen analogy, what happens if consumer demand dries up and they are suddenly only getting orders to bake 50 cakes a day again, but they still have to pay the rent for the giant brand new kitchen they just built?
That is exactly the risk scenario that keeps manufacturing CEOs awake at night. If a macro downturn hits India and the auto OEMs decide to destock, meaning they stop ordering new parts from suppliers and just bleed down the inventory they already have in their warehouses to save cash, OBSC's order volume plummets overnight.
But the bills don't stop.
But the depreciation on the SUPA plant, the maintenance on the new CNC machines, the fixed overhead, none of that goes away. In that scenario, high fixed costs turn from a massive blessing into an absolute curse.
How bad could it get?
Well, projections model a scenario where a 20% to 30% drop in factory utilization could erode their EBITDA by 30% to 40%. The operating leverage works in reverse, viciously amplifying the pain on the downside.
That is a severe potential hit to their profitability. And they are also exposed to the raw materials themselves, right? We talked about steel being their main variable cost and how they have a geographic advantage, but they don't control the global price of the metal.
Yes, input cost volatility is a constant lingering threat. The prices of specialized steel, aluminum, and brass fluctuate daily on global commodity markets.
Based on what?
Based on mining output, global demand, and geopolitical events. If those prices spike sharply, and OBSC cannot immediately pass that increased cost onto their OEM customers because, for example, they are locked into fixed price contracts for the quarter. Their margins get squeezed directly and painfully.
They just have to eat the cost.
They do. They have some protection through their Anglian Omega Group bulk purchasing power, but a severe, sustained global commodity shock would absolutely still hurt them.
Okay, those are the operational factory floor risks. But as I was reviewing the financial statements, there was a specific glaring quirk in the numbers that felt like a real mystery to me.
I think I know what you're talking about.
It has to do with their cash flow. And I want to spend some time unpacking this because it feels critical.
I know exactly what you're referring to, and you are right to highlight it. It is a crucial detail for anyone trying to assess the true financial health and liquidity of the company.
The data reports their operating cash flow at a staggering 884.9 crores. But in the exact same period, their actual reported profit, their PAT, or profit after tax, is listed at only 26 crores.
Yes.
Let me repeat that. Operating cash flow of almost 885 crores, but actual profit of 26 crores. That is a gigantic canyon-sized gap. The cash flow is roughly 34 times higher than the net profit.
It's a very striking divergence.
Mathematically, for a company with a few hundred crores in revenue, how is that even possible? Is it an accounting error?
It is a stark, almost startling divergence. And while we have to analyze the numbers exactly as they are reported in the filings, a gap of that extreme magnitude usually points to significant non-cash working capital dynamics at play, or potentially a large one-off event.
How does that work?
Operating cash flow essentially measures the actual cash entering and leaving the bank account from the core business, while net profit includes all sorts of non-cash accounting adjustments like the depreciation we discussed.
Okay, but depreciation alone can't explain an 850 crore gap.
No, it cannot. To understand the friction causing this, we need to look at another vital operational metric, their working capital days.
Right. The data notes that their working capital days are creeping up and currently sit at 88.7 days. What does that actually mean in practice?
Let's connect these dots. Working capital days represent how long it takes a company to convert its operational investments like raw materials and labor back into actual cash in the bank from sales.
Okay.
In the auto ancillary world, the major OEMs, the huge car companies, wield immense power. They are notorious for paying their smaller suppliers very slowly.
Because they want to keep their own cash.
Exactly. They want to hold on to their cash for as long as possible to fund their own operations. If OBSC delivers a huge batch of shock absorber rods today, they might not see the actual cash payment for that delivery for 60 or even 90 days.
Wait, so OBSC pays its workers today, uses the steel today, ships the product today, but essentially acts as a free, interest-free bank for the giant automaker for 3 months.
In essence, yes. That is the harsh reality of being a Tier 2 or Tier 1 supplier. As OBSC is growing rapidly, signing new contracts and shipping more and more product, the absolute amount of cash tied up in these unpaid invoices, what accountants call accounts receivable, grows substantially.
So even though they have that geographic cheat code that gives them 30 to 35 days to pay their own steel suppliers, they might be waiting up to 90 days to get paid by the automaker.
Exactly.
That creates a nearly 60-day gap where they're out of pocket. They have to finance that gap somehow.
And that gap is where the friction lies. If a cyclical downturn hits, and those powerful OEMs decide to stretch their payments even further to protect their own balance sheets, say, pushing payment terms from 90 days to 120 days, OBSC could face a sudden, severe cash flow crunch.
Because the cash isn't coming in.
Right. Even a highly profitable, rapidly growing company can literally suffocate if they run out of actual liquid cash to pay their staff, pay their electricity bills, and keep the factory lights on while they are waiting for customers to pay millions of rupees in outstanding invoices.
And what about that 885 crore cash flow figure?
As for that massive 885 crore cash flow figure, it could represent a large upfront advance payment from a client, perhaps tied to that 10-year defense contract, or a rapid liquidation of built-up inventory, artificially inflating the cash pile for one reporting period, while the underlying profit remains tied to the slower delivery schedule.
The cash flow is at king, and right now their cash cycle is stretching. But the filings also show their overall debt burden is quite low, right? They report a debt-to-equity ratio of just around 0.40x.
That low debt level is their saving grace right now. Because their leverage is low, meaning they haven't borrowed excessively from banks, and their interest coverage ratio is very strong, they have a solid financial buffer.
So they aren't going to go bankrupt tomorrow.
No, they aren't currently under distress from creditors, but that creeping working capital intensity taking nearly 90 days to cycle their cash is a structural vulnerability.
It's a drag on the engine.
Exactly. It is the friction in their financial engine. It is something they have to manage meticulously as they scale, or it could act as an Achilles heel if the broader economy slows down.
So what does this all mean for the overall picture? We have a company with brilliant, deeply entrenched geographic advantages, a bold, high-margin strategic pivot into defense and robotics exports, and sprawling new megafactories coming online to drive operating leverage.
A lot of positives. But on the flip side, they are facing real, unavoidable cyclical automotive threats, commodity price risks, and creeping cash flow friction as their customers take longer to pay. This inherent tension leads us directly into the market debate. How is the outside world, the broader market, pricing all of this in?
The prevailing narrative in the market right now is heavily weighted toward the optimistic side. The market is essentially pricing in perfection.
Pricing in perfection, that is an incredibly high bar for any manufacturing company to clear.
It is. Valuations place their PE ratio somewhere between 29 and 57, depending on the exact trailing time frame you look at.
And what does that suggest?
It suggests that the market fully expects OBSC to execute this complex pivot flawlessly. The market expects the company to navigate the auto cycle, maintain stable operating margins near 18%, and crucially, to actually deliver on that blistering 40% to 55% revenue growth year over year without faltering.
Okay, so let's set up the checkpoints. If you're following this story and want to see how it plays out, what is the bull case that justifies that kind of high-flying optimism? The bull case requires three major things to align perfectly. First, the underlying demand from the Indian auto OEMs must stay red hot. There can be no cyclical slowdown, no recessionary destocking.
Okay.
Second, the new physical capacity, especially that sprawling super plant, must hit high utilization rates, like 80% or more, very quickly.
To get that operating leverage working.
Exactly, turning those fixed costs into a margin advantage. And third, the defense and aerospace pivot must execute without a single hitch. That 130 crore anchor order has to translate smoothly into delivered product and recognized revenue, and they need to continuously win new contracts in those high-margin spaces.
And if they do all that?
If all that happens, the margins expand, the net profits surge, and the high valuation is completely justified by the sheer growth.
And on the flip side, what is the bear case? What are the skeptics and the pragmatists watching for?
The bear case looks at the recent history and asks a difficult, probing question. Was that huge 54% revenue jump in FY26 a permanent structural change in the company's trajectory, or was it just a one-time cyclical OEM ramp-up following a period of underordering that won't be repeated?
Because if it was a one-time thing, the growth projections are completely off.
Exactly. The bears warn that if auto demand cools even slightly and revenue growth slows down below 30%, the financial math changes drastically.
The operating leverage turns on them.
Right. And if you combine slower top-line growth with those creeping working capital days pushing past 90, tying up cash, the strain becomes apparent quickly. In that scenario, the current high valuation will look very stretched, and the market narrative will likely turn punitive as expectations reset.
So for you listening right now who wants to track this real-time corporate case study, what are the vital signs you should be monitoring? If you could only look at two numbers on their quarterly reports, what would they be?
I would advise looking past the flashy top-line revenue numbers and watching two specific operational metrics that tell the true story of the factory floor.
Okay, what's the first one?
First, watch their capacity utilization rates. Are the machines in the new megafactories actually running and cutting metal? If utilization drops, profit margins will inevitably follow downward due to the sheer weight of those fixed depreciation costs.
Right. The rent is due whether you bake the cakes or not.
Exactly. Second, watch their working capital intensity. Are they actually getting paid on time by their giant OEM customers?
The receivables.
Yes. If receivables stretch further and cash flow diverges even more from reported profit, it's a glaring red flag for liquidity strain, regardless of how many fuses they are shipping.
It is a delicate, high-stakes balancing act. They're sprinting on a tightrope while juggling steel and defense contracts.
That's a great way to put it.
Let's recap this incredible journey we've unpacked today. We started with a regional manufacturer in India, churning out millions of shock absorber rods and exhaust sensor mounts for heavy trucks and passenger cars.
Yeah.
A company built on a brilliant geographic cheat code, physically co-locating with steel suppliers in Pune and Chennai to slash logistics costs and maintain a vital edge over massive conglomerates.
A very strong, highly profitable foundation, but ultimately one with a structural ceiling dictated by the auto industry.
Exactly. And from that solid foundation, we watched them attempt a high-speed, high-stakes pivot. We saw them leverage their intense, certified precision engineering capabilities to break into the zero-tolerance defense sector, scoring a 130 crore 10-year anchor order for artillery fuses.
Which is still crazy to think about.
It is. We saw them expanding their export footprint to 17 countries, aggressively riding the China +1 geopolitical wave. We even saw them actively preparing to machine complex joints for next-generation humanoid robots.
The future is now.
And all of this is being funded by significant capital expenditure, raising funds to build megafactories aimed at unlocking immense operating leverage.
While simultaneously and quietly having to navigate the very real, very heavy threats of auto industry cyclicality, volatile global steel prices, and the relentless daily pressure of managing cash flow when your largest customers essentially demand that you act as their bank for 90 days.
It's an absolute masterclass in how a mid-sized manufacturer attempts to evolve into a global, multi-industry player. We've covered the mechanics, the money, and the strategy. But before we wrap up this deep dive, I want to hand it over to you for one final thought.
Sure.
We established early on that OBSC's deepest competitive moat today is distinctly physical. It's their geographic co-location right next to their steel suppliers, allowing them to cut out middlemen. But as we look to the future, does that physical advantage hold up?
That is the exact question we should be asking. Think about where global manufacturing is unequivocally heading. We are rapidly entering an era driven by AI-assisted generative design and the rapid, accelerating globalization of advanced 3D printing, specifically additive manufacturing for complex metal parts.
Right, it's becoming more digital.
As manufacturing becomes increasingly digitized, where the true value lies in the proprietary software file and the algorithm, rather than the physical stamping press or the proximity to a steel mill, we have to ask a tough question.
Which is?
Will geographical proximity to raw materials still be a dominant competitive advantage 10 or 15 years from now?
Or will it not matter at all?
Right. Or will the intellectual property of the design, the digital certifications, and the proprietary algorithms running the 3D printers be the only real moats left? If the future of manufacturing is decentralized and entirely digital, does a geographic supply chain cheat code eventually become completely obsolete?
That is a fascinating, mildly terrifying thought for traditional heavy industry. Something for all of you listening to ponder the next time you hit a pothole and rely on that invisible metal rod.
Absolutely.
Thank you for joining us on this deep dive into the mechanics of manufacturing and corporate strategy. Keep questioning the systems around you, and remember to keep looking beneath the surface of the everyday objects and the invisible connective tissue that keep our world moving.